Memory and coding agents like Claude Code actually makes your coding agent dumber. All these memory tools are doing is simply injecting irrelevant information into your agents and distracting them from the tasks at hand. And this is because your agents don't actually remember you. They are entirely stateless. But that's actually a good thing, because it means you can control exactly what enters the memory of your agent at all times, giving you the power to keep it focused. In this video, I'll show you the proof behind why more context actually decreases the performance of your agents and the two elegant solutions that allow you to create your own memory systems for your agents. By the end, you'll have the tools to build memory systems that actually fit your workflows even in production level systems. I'm Roman. I published a top 3% paper at NeurIPS, the largest AI conference in the world. Now I'm on a mission to push coding agents to their absolute limits. So why do we not want to use memory tools? Well, just like humans, agents have finite attention. Memory tools auto-inject information into the context window, regardless of if it's relevant to the task at hand. As a result, agents must spend their valuable attention on these memories. As a motivating example, think about trying to code a local application for your family. All of these pre-built memory tools are actively injecting context that will distract the model from actually building that application. As a result, the quality of the application suffers. And in some cases, the memories contain contradictory information that misleads the model. That's called context poisoning, and it's more common than you'd think. So as you can see here, the actual task at hand is not getting nearly enough attention to be done properly. The more attention to a task at hand, the better it's going to be done. So memory tools gather more and more memories about you. Context rot sets in, the agent gets increasingly distracted by irrelevant information. Either Claude Code or the memory tools start compressing by summarizing or removing information, and then this compressed information eventually becomes so distracting that the model's intelligence drops far below what it was without these tools. We call this context collapse. Every one of these tools uses Claude Code hooks to inject context the moment your session starts. None of them ask whether or not the context is relevant to what you're about to do. So the first core alternative is a knowledge base that you or your agent can query on demand, which means nothing will enter context until asked. So in reality, it's incredibly easy to set up on-demand knowledge for your agents. At bare minimum, all you need is a simple file base. Then you can start adding more and more stuff. What I do is I start with a simple knowledge base of markdown files that I can query with parallel subagents. What this looks like is basically well-labeled markdown files with certain tags, maybe a date, and also related notes that we can wiki link to. This is basically how Obsidian works, the knowledge base tool. So you can build it in Obsidian or just build it in a file base. You don't need anything but files. Markdown is the way we get memory into agents. At under 100 nodes, this is basically all you need. Even under 500, this is effectively all you need because of the power of agentic RAG and parallel subagents. So what we're going to do now is we're going to show a live demo of this in action, okay? So basically what this is going to look like is we're going to CD into our knowledge base, which is in Claude Memory/Sessions. And basically what this is a record of all of the sessions I had in a 1 month period, I think 2 month period between January and March. Basically, what I did is I had a Haiku agent summarize every single session I did with a post-session hook. So we're just going to start Claude up in there, and we're going to say something along the lines of spawn 5 parallel subagents and tell me the concepts that have been my main focus over the months in 2-week blocks related to agentic coding, concepts, and teachings. Now, I know what you're thinking. Roman, this takes ridiculously long. Well, yes, it does take a long time to properly query a knowledge base of this scale. And however, for smaller knowledge bases, you can always get creative with on-demand RAG, which is basically where you embed the knowledge base into vectors with an embedding model, and then you query via cosine similarity of those vectors, which is basically called vector search. And then you can also possibly filter and have inject patterns for knowledge bases. So here it goes spawning the agents. So let's wait for these to finish and I'll show you what that looks like. So as you can see, after we're done waiting, all 5 agents return. And by the way, this corpus was 3,417 summarized sessions from Claude Code. If that's not a giant corpus of information, then I don't know what is. So basically, it's grabbing all of this data, which it read with parallel subagents and then synthesized down for me. And the cool thing about this is I can ask follow-up questions. And if you're worried about waiting a long time, you guys can put this in your automated pipeline so that it's running in the background when you need it. And so basically every single thing that I've gone through in my agentic coding journey is on here. It didn't forget very much because we do this heavy duty search of the database. And some of this actually got deleted because of a bug in the code, but you can see there's a lot of this stuff. And basically it even tells me an arc. So if I wanted, I could ask it to write me some suggestions for what I should study next based on this learning arc. So we can do whatever we want with this data. So yeah, as you can see, now we have some suggestions on what I should learn next. Guys, this is the best way to have actual memory. Now, what if we wanted a quick and instant way? Look no further than method 2 for persistent memory in your agents. So here's the second core pattern, and it allows dynamic memory injection at absolutely any time based on a keyword. Basically, we use hooks, which are deterministic shell commands which fire according to an event. And in our case, the event is going to be every time a user sends a prompt, this will cause the hook to fire and check if a keyword was in your prompt. Then if the keyword was in your prompt, you can inject memories related to it. For example, let's say that my school community, the Agentic Lab, is something that I want Claude to remember. Instead of putting it in a memory.md, which gets consistently loaded when it shouldn't, and gets bloated and eventually Agentic Lab gets forgotten, I can just create a hook which fires every time I say Agentic Lab into Claude Code, and it will deterministically replace or add context about what the Agentic Lab actually is. So this will cause an injection into my prompt, such as the Agentic Lab is a community hosted by Roman, which teaches people to master agentic code. And we can stack many of these every time we want our agent to remember something about us, a specific pattern or our work. This is the opposite of what naive memory tools do. Memory tools auto-inject memories every session whether you need it or not. So why not skills? Well, skills inject only according to the agent's whim, or have to be placed at the beginning of context in order to auto-inject as a slash command. Now on top of all of this, hooks can be called to inject memories outside of just user prompts. So we could inject memories during sub-agent spawns, pre-compact, or other crazy ways. With hooks, the only limit is your skills with agents and your creativity. Alright, so now we're going to do a relatively simple demo of how to actually set up and think about this hook. So step 1 will be a simple regex match. Step 2 will be deduplication. So if we don't have a hook that injects memories, we don't want it spamming the memory every time we say the keyword in a conversation. Now step 3, if we do get a repeat mention of the keyword, we just put in a one-line reminder. And then step 4, finally, we have to think about a keyword such that you would only ever say it if you think the model should have this context injected, which means like a non-common keyword, like something unique. Then you can do this absolutely anytime there's a term you want the model to instantly understand. This is dynamic memory. So what does this actually look like? Well, let's run through the demo. So let's go into here, and I'm going to say create a user prompt hook with the following logic. So 1, check for Ralph Loop or Ralph Wiggum or Ralph in the text. So the last one is just if it gets dictated, it sometimes says that. So if there's a match, inject Ralph Loop. So we're going to do definition, and it's basically a bash while loop. I'll go ahead and copy this from my corpus. And what this is going to look like is this. And then we can, I already put the closing tag in there. So then we can say number 3, prevent duplication by having one state file per session where we grep for the keyword string. And if it doesn't exist yet, add the keyword string to the file. Okay, so relatively simple. And we'll see what happens. All right, so very simple. It went ahead and wrote the hook according to the specifications I just gave it, and it added it to the Claude settings.json. And basically, it matches the words Ralph Loop, Ralph Wiggum, or Ralph, and it's case insensitive. On first match, it injects the full Ralph Loop definition, which I gave it. And then on subsequent matches, it injects a short, already loaded reminder. And then we have the state actually tracked. So that's all we need. So let's restart and see what happens. We can ask, what is a Ralph loop? And then we just wait. And hopefully it will have instantly injected the context. Look at that. It knows exactly what a Ralph loop is immediately, right? So I don't have to play the game with waiting for our model to call a skill or query a knowledge base or anything like that. That information just gets deterministically added every single time. Be careful. You don't want to do this in cases where it's a common word or in cases where sometimes you don't want these memories injected. You have to be smart about this. We're engineers, right? And remember, your agent doesn't need to remember everything. It just needs to know where to look. The memory tools are solving a real problem. Agents do indeed need persistent knowledge, but auto-injecting that content every single session, whether or not it's relevant, is the wrong architecture. You got to build a queryable knowledge base. You structure it with tags and wiki links. Make it easy for the agent to search and you will be rewarded. And then if you need quick and instant memories, you can add hooks over time. So instead of typing out /memory or whatever your / command is to have the model remember what you're saying, just have it add a hook. Make a / command to create that hook instead. Linked below is the best community for mastering Claude Code, and I just released a free course in there to get you started called Claude Code Essentials. I'll see you in there.